In this video, we're going to look at some of the polynomial identities that we'll come across. So we're looking here, this concept, a mathematical statement that equates two polynomial expressions is an identity if one side can be transformed into the other side using mathematical operations. Basically, it's saying if we can show that both sides are equal, we have an identity. And these polynomial identities are useful or helpful tools used to multiply and factor polynomials. So we'll use these to go back and forth between multiplying terms out or polynomials out, as well as factoring polynomials. First, I want to go through the four of the most common ones that you'll see. This first one, difference of squares, you should be pretty familiar with this. I'm just going to do a lot of highlighting with these, and we'll try and, everything's already been written out, so just try and connect the dots and see what goes where. So difference of squares is when you have a squared minus b squared. And what's important to remember is that these can go in both directions. So we can work left to right. Sorry about that. We can work left to right or right to left. And sometimes you'll see this difference of squares and you'll need to factor it. And other times you'll see these two binomials and we'll need to kind of multiply them out. The nice thing about these polynomial identities is it's going to save you some work when multiplying, and it's going to make factoring possible. All right, so occasionally when you come across these, it doesn't look like they're factorable, but in fact they will be. So an example of this, which I keep changing colors here, would be this 25x squared minus 36y squared. And what's going on here is we're looking for what is kind of this squared. What is this a squared minus b squared? And this is really 5x squared minus 6y squared. And this 5x is our a value, and this 6y is our b value. Now, this one is not overly complicated. You'll see when we get to the cubes, there's more going on. But what you're doing is you're going to take those a and b terms, and you can plug them in. And then you can just use your formula to kind of figure out what goes where. All right, so it's kind of, might seem intuitive. It might seem like you have no idea what's going on. But the idea is that you should be able to go back and forth, again, over on this left side, from the left side to the right side of the equation. So let's look at the square of a sum. In the square of the sum, now we have a plus b squared. This one is just going to save you time. You would be able to do this by hand if you wanted to. You could both multiply this out to get here, and you could work here from the right side to the left side factoring. So the square of a sum, that identity is really just going to be used to save you time. So here we have 3x, and I'll just stick with these same colors, and 4y. So your a value, your b value, and then those a values are going to be used twice, and the b values will be used twice. So 3x is our a, 4y is our b, and then what we're going to do is we're going to use, so this here is being transferred. All right, so we're using this a plus b squared. This a, sorry, not a plus b squared, a plus b quantity squared right here, and we're going to rewrite it using our identity. That's not the color I wanted. So this 4y is used, and then I already highlighted part of the 3x. And then you would just work this out. And once this is simplified, 3x squared is 9x squared. 2 times 3x times 4y would give you this 24xy, and 4y squared would give you 16y squared. Now you might ask, all right, what is this useful for? What this does is it'll save you time. So instead of having to do 3x plus 4y times 3x plus 4y and distribute, and get your terms, so we wind up with all these terms here, it's just going to save us time. All right, it'll be a shortcut for difference of squares and sum of squares, square of a sum. It's going to save you time. You would be able to do both of these, again, these two, manually. You would not need to know the difference of squares rule or the square of a sum rule. You would be able to multiply or factor without them. However, when you get into the difference of cubes and the sum of cubes, these are ones that are going to save you a significant amount of time, energy, and stress. So the difference of cubes is going to be a, so we'll have a couple a's here, and then b cubed, and then b will be there. So the difference being subtraction, cubes being cube root, so to the third power. When you're doing these, we do want to be careful with the numbers that we use as a and b. In the example, 8 is not our a value. All right, 8m cubed is the same as 2m cubed, and then 27 is a perfect cube where 3 would be cubed to get 27. The most common mistake is taking the numbers that are already there and using those as your a and b. Okay, we don't want to use the numbers that could potentially be there. We might have to change them, and most of the time you will. So what's going to happen is in this case, we actually want to use 2m as our a value, and 3 is going to be our b. I don't know why that 3 is so large there. So that 2m is going to be replacing the a in your formula, your identity, and then that 3 is being plugged in as your b value. So again, you're taking this identity here, and you are substituting your 2m and 3 into the identity. Once you simplify that, the 2m minus 3 pretty much stays the same. 2m squared would give us this 4m squared. 2m times 3 is 6m, and 3 squared is 9. These are the ones where you're really going to want to know them. All right, they're going to save you a significant amount of time, this difference and sum of cubes. Because otherwise, what I would have had to do, let me write this out real quick. One, I wouldn't even know where to begin factoring this. All right, 8m cubed minus 27, I wouldn't even know where to go. But let's say we had it the other way around. If I had this 2m minus 3, and then the 4m squared plus 6m plus 9, I would need to distribute all of this. All right, and I'm going to wind up with, what do we have? 6 different terms here. I'm going to have to combine like terms. I'm going to have to make sure I don't make any mistakes with that. Whereas by using this difference of cubes rule, this identity, again, it's going to save me time where I can just jump right from the cubed, a cubed minus b cubed, to the written up form of the identity, or the more lengthy part of that identity. Right. I know there's a lot of highlighting and a bunch of scribbles here, but hopefully you're sticking with me. The sum of cubes is very, very similar to the difference of cubes. The only difference is going to be the signs. You'll see here you have a subtraction, here we have an addition sign, and then the rest of it, it's subtraction, addition, addition, whereas down here it's going to be addition, subtraction, addition. There is a method to remember how this is set up. I'm not going to go into detail with that in this video. I just want to show you what the identities are and really how to approach them. So this final one, I'll work on that highlighting again. We have our a values, we have our b values, and again, I can't stress it enough. Be careful, just because this G is here and this 64H is here, that doesn't automatically mean they're your A and B values. For this one, the G is pretty direct. All right, G is your A value. We don't have to change in that. However, the 64 is not the B value. We need to figure out what is the cube root of that 64. So that would be 4H cubed. And now I can use that 4H as my B. So that's the only part where you're really going to have to do a whole lot of work and that you have to be careful. And like I mentioned with the difference of cubes, that is by far the most common mistake. So be careful there. Let me finish highlighting this. So we plug in our G values into our identity. We plug in the 4H, again into our identity. That's this here, getting substituted. And then when you multiply them out, that first term here, that's just going to stay the same. Well, there should be a 4 here. And then g squared minus 4gh plus 16h squared. And that would be, again, these three terms being kind of cleaned up and simplified. So just to kind of cover everything that we've talked about here in a quick little statement, the difference of squares and the square of a sum, our first two methods, these two, you could do those without really memorizing what the identities were. You'd be able to factor and you would be able to multiply. It might be a little bit more work, but you would be able to do it. The difference of cubes and the sum of cubes, these two down here, you need to be familiar with those. All right, they're going to save you a significant amount of time. And if you get a statement, let me highlight one thing. If you get a statement like this, if you don't know the difference of cubes, you're really not going to be able to factor that. It's going to be incredibly difficult. It's going to be a lot of work that you're trying to figure out. The difference of cubes is going to allow you to separate that and break that into this longer statement here and eventually here. So make sure the difference of cubes and the sum of cubes you are becoming very familiar with. They're going to make your life significantly easier in terms of Algebra 2 and eventually pre-cal and calculus.